So if you've ever used a large language model for work, you've probably run into this. You ask it a simple question about one of your internal systems, and you get back a completely bizarre, made-up answer. You ask about some specific error code, and it gives you a recipe for banana bread. It's frustrating, right? Well, today, we're going to dive into exactly why that happens, and more importantly, how engineers are fixing it with a really powerful pattern called RAG. Let's start with the root of the problem. This quote right here, it just hits the nail on the head. Your AI isn't dumb. The real issue is that it has absolutely no memory of your conversations, and, this is the big one, it's completely blind to your private, internal, or real-time data. It's not just operating in a vacuum, it's totally cut off from all the information that you actually care about. And this slide, it lays out that vacuum perfectly. Over on the left, you've got the LLM's brain. It's all the public data from the internet that it was trained on, which, by the way, is already getting old and is totally static. But on the right, that's what you actually need it to know about. Your company's private docs, your real-time server logs, the latest support tickets. There's this massive, massive gap between what it knows and what you need it to know. So how in the world do we bridge that gap? Well, the industry standard solution is this really elegant pattern called RAG, which stands for Retrieval Augmented Generation. I absolutely love this analogy because it's just so accurate. RAG is basically the adapter that connects the LLM's incredible reasoning engine directly to your living, breathing data sources. It's like giving that blind model a pair of glasses so it can finally see your world. Okay, so let's break that down. What is RAG, really? It's basically a two-step process. Before you even think about asking the LLM to generate an answer, you first retrieve relevant info from your own data. Then, you package that context up with your original question and send the whole thing to the LLM. So it's not just ask, it's retrieve, then ask. And this diagram here shows the whole system in action. See, way over on the left, you've got your data sources, your docs, your logs, your tickets, all that stuff. That raw data gets processed and stored as something called embeddings in a special vector database. Now, when a user asks a question, the system doesn't just shoot that question over to the LLM. No. First, it does a super fast search in that database to find the most relevant context. Then, and only then, does it bundle that fresh context with the user's query and send it to the LLM to get a smart, grounded answer. If you remember just one thing from all this, let it be this mantra right here. This is the entire RAG workflow in 4 simple words. Instead of just asking and, hoping for the best, you're giving the model the tools it needs to give you a fact-based answer. Ask, retrieve, then answer. So that's the big idea, but how do we actually build it? That's where our engineering guide kicks in. All right, let's get our hands dirty and talk about the build. The very first and probably most critical step is getting your data ready so it can be retrieved in the first place. This is the pipeline that turns all your raw information into searchable knowledge. So this breaks down into 3 key parts. First, you've got to ingest your data from wherever it lives. PDFs, Confluence, Slack, logs, you name it. Second, you have to chunk it up. You're not going to feed the model a whole 100-page manual at once, right? You want to break it into small, meaningful paragraphs or sections. And finally, this is where the magic happens. You convert those text chunks into these numerical representations called embeddings. Now, embedding might sound super complex, but the idea is actually pretty simple. Imagine you have a giant map of meaning. An embedding is like giving every single concept its own unique coordinate on that map. So ideas that are semantically similar, like high CPU usage and my server is super slow, they're going to be located really close to each other on that map. This long list of numbers, the vector, it's just the address that pinpoints the meaning of that piece of text. Okay, so once all our data has a coordinate on our map of meaning, we need a way to search through it, like really fast. And that brings us to step 2, actually implementing the vector search. This is the real-time part of the whole system. First, you take all those embeddings and store them in a special kind of database, a vector database, that's built for this kind of search. Then, when a user asks a question, you do the same thing to their question. You turn it into a vector and find its coordinate on the map. And then you just ask the database a simple question. Hey, which of my data chunks have coordinates that are most similar to this question's coordinate? And this visual just brings that whole process to life. You can see the user's query, how do I fix high CPU usage, getting turned into its own vector. The system then zips over to the database, which is packed with vectors from all your documentation and past incidents. It instantly pulls out the text chunks that are most numerically similar, gets that context ready, and prepares for the final step, the generation. And this, right here, is the most crucial point of all. You take the user's original question, you add that rich, super relevant context you just found, and you send that entire package to the LLM. You're essentially giving the model an open book test, and you're handing it all the notes it needs to ace it. And the results of that test? Well, they're like night and day. So, what's the big payoff for all this engineering work? Let's take a look at the pretty dramatic difference between a standard, off-the-shelf LLM and one that's been grounded with RAG. And here it is. I mean, look at that. Without RAG, you're stuck with hallucinations, outdated knowledge, and just generic answers that don't really help. But with RAG, the entire game just changes. You get grounded responses that are based on your real, up-to-the-minute data. The answers are context-aware because they are literally using your data to think. And this is exactly why engineers are adopting RAG so fast. You don't have to spend a fortune retraining a whole foundational model. It's actually pretty easy to integrate into your existing systems, it works with the data you already have, and it gives you this immediate, massive boost in accuracy and reliability. Honestly, it just works. And that really brings us to this powerful conclusion here. For anyone who's building a serious production-grade AI system, like an internal copilot for your company or an assistant for your site reliability engineers, RAG isn't a nice-to-have anymore. It's a fundamental requirement if you want to build something people can actually rely on. So, I'll just leave you with this final thought. Right now, if you're using a vanilla LLM, it's just making educated guesses based on old public data. By implementing RAG, you're giving it the facts. So the real question is, isn't it time to stop all the guesswork and ground your AI in your reality?